Welcome back. All right, so we're going to do a few problems together with end behavior. All right, so we're going to describe the right hand. So when it says right hand, we're going in the positive direction. That's as x goes to positive infinity. And left hand, that's the negative direction. That's as x goes to negative infinity. And even though you can't see me, when we're talking right hand, I'm pointing to the right, and as I'm saying left hand, I'm pointing to the left, and absolutely nobody but the chairs can see me. And they don't have eyes. All right, so let's look at our equation here. We have the equation written down below, and there we have our graph. We have f of x equals negative 2x cubed plus 5x squared minus x plus 1. We look to the largest exponent, and that's negative 2x cubed. All right, so that means our degree is 3. Which is odd. And once we know it has an odd degree, we know our ends are going to go in opposite directions. Then we look to the leading coefficient, and that tells us which way it starts, which way it ends. Right? As it's going to negative infinity, which way is it heading that direction? Which way is it going as it heads to positive infinity? All right, so as x heads to negative infinity, and as x heads to positive infinity. So the leading coefficient is negative 2 because that's the coefficient that's in front of x cubed, and that's a negative number. So I have how to think about it and how to note it. Right? So there's two different things. Right? Make sure you don't note it the way you're supposed to think about it. Right? The think about it just helps you figure it out. The note it is the way you gotta write it. Okay, and we're going to do many more examples, and I got a lot. I have them in on the next slide in your notes. So let's look at here. We have if our degree is odd, and the leading coefficient is positive, right? It's going to start low and end high. If the leading coefficient is negative, instead it's going to start high and end low. And so when we're thinking low, that's negative infinity. When we're thinking high, that's positive infinity. When our degree is even and the leading coefficient is positive, greater than 0, we're going to start high and end high. Right? And high means infinity. If the leading coefficient is negative, less than 0, it's going to start low, end low. And what does low mean? Negative infinity. Right? So that's how you can think about it. Here's how you note it. All right, so we want to write the end behavior. It always starts with the function, because we want to know what the function is doing. X, that's going to positive infinity, that's going to negative infinity, it's going everywhere. But what's the function doing? All right, so f of x is going to go to what as x goes to negative infinity? Well, we know it's odd, our degree is odd, and the leading coefficient is negative. So it's going to start high and end low. Right? So negative infinity, that's the starting part, right? It doesn't really start, but when we look at it in the graph, right, and we start to draw it, right, it's starting high. Where does high head to? High heads to positive infinity. There we go. All right, so f of x approaches infinity as x approaches negative infinity. As f of x is going this way, as x goes that way. And there's always two sides, right, of our end behavior. What happens is x goes to the negative side. What happens is x goes to the positive side. F of x is going to go to what as x goes to positive infinity. Right? So now it's going to start high and low. What does low mean? Low means negative infinity. It's going to go towards a negative infinity. All right, so as x goes this way to positive infinity, y's, and that's x, the function is going this way to negative infinity. All right? So you can remember your directions, right? So just think of it like a line, right? So a line, when we go to draw it, and if it has a negative slope, we start high, read it left to right, right? So we start high and we end it low, right? And just remember, every time you're thinking high, you're thinking positive infinity. Every time you're thinking low, you're thinking negative infinity. Got it? All right, so here it is all summed up for you. And this came in many evolutions until it looks like this. And this seems to have the best information for helping students remember all of the little pieces on the shapes and the end behavior. This has got everything all summed up in one table. I'm quite proud of it, actually. It's got your basic shape. It's got your end behavior noted. It's got your degree, is it even or odd? And it talks about your leading coefficient. It's got it all, right? So everything for end behavior in one nice little table there for you. Let's start in the upper left corner. Even degree, leading coefficient is positive, right? So we have essentially two shapes. A U shape, so this would be, and if you want we'll write a little equation for it. All right, so the one that's a U shape, right? That would be, for instance, f of x equals x squared, right? And then the x squared could have anything with it, right? That's still going to have that U parabola shape. Doesn't matter how many things we add to that. Also, if we had, up to my or there, f of x equals x to the fourth, that would have that shape. Now the W shape is going to be for, I'm going to switch colors, I don't know. You know what, I should switch colors, and I should switch to a color that's not up here, because if you notice, it's kind of color coded. Let's do purple for example equations. And then you won't get it confused. We'll just do purple for all of them. And I'm just going to change those words to purple. There you go. All right. So purple will be for the sample equations, right? And so I'll just put a little EX for example. And I'll do the same thing over here, right? So for the W shape, an example would be f of x equals x to the fourth plus ... And let's move this guy over a little bit. All right, so if you've got stuff, right, other terms than just an x to the fourth in your equation, right, then it's going to have that W shape. And the more stuff, the more W-ishy it looks. That's a new word, W-ishy. All right, so those are your two basic shapes, right? And for even degree and leading coefficient positive, right? Both ends are going up. Our end behavior is notated. F of x approaches infinity as x approaches negative infinity. F of x approaches infinity as x approaches infinity, right? Whether x is approaching negative infinity or positive infinity, the function is going to be approaching infinity because both ends go up. It's like a cheerleader. Rah, rah, rah. Both ends go up. All right, so now look at even degree. Leading coefficient is negative. Basic shape, again, it's going to have a U, but this time it's going to be an upside down U. All right? So some example equations. Very similar to the other page there, or the other side. And so these would be our examples. F of x equals negative x squared plus, we can add all we want to that, it's going to maintain that parabola shape. Or f of x equals negative x to the fourth. Right? If you add much else with it, it's not going to have a parabola shape, it's going to have a W shape. Right? So an example of a graph that would have this shape, where am I going to squeeze this in? It would be, for instance, f of x equals negative x to the fourth plus ... plus stuff. And the more stuff, the more it starts to look like a W. And how will you know it's going to look like a W or a U? Well, we're going to learn how to graph them and how to find the key points, and then you'll know if it looks like a W or a U. Right? But I want to kind of give you the idea of when it will look like a U. So if there's nothing really added to your leading term, when it's not an x squared, or if you just add a constant, right, that's not going to change the shape. But if you start adding x cubes and x squareds and x's and constants, all those things together, then you get a little bit more of a nice little W pattern. But it doesn't change the end behavior. It's because the end behavior for an even degree, leading coefficient negative, is going to be f of x will approach negative infinity as x approaches negative infinity, and it will approach f of x will approach negative infinity as x approaches infinity. So no matter what x is doing, right? It's got his arms down by his side. Maybe he's sad, right? His arms are down by his side, right? Both ends are going to go to negative infinity. Right? And now we have our odd degree. Right? And our odd degree is always going to look like an S. Sometimes it's got a little bit more wiggles in it. If we add, same thing, if we add things to it. Right? And a few less wiggles if we don't add things in. Right? So odd degree, leading coefficient's positive. There's our basic shape. I'll give us a basic equation. Right, even though it's only one shape. Right, so example, f of x equals x cubed, and then we could have some stuff, right? Or f of x equals x to the fifth, and we could have some stuff, right? It'll still have that SE shape. Notating end behavior, f of x, I was going to approach negative infinity as x approaches negative infinity. F of x approaches infinity as x approaches infinity. Going to go the same direction. Right? They both are going down. They both are going up. If that leading coefficient is positive. If it's odd degree and the leading coefficient is negative, still SE shaped, but it's going the other way. So example equations would be f of x equals negative x cubed plus, it could have stuff with it, or f of x equals negative x to the fifth, and it could have stuff with it. How to notate end behavior is f of x approaches infinity as x approaches negative infinity, so it's reversed. F of x approaches negative infinity as x approaches infinity. Right? So everything about your shape, your end behavior, and when that's going to happen, all summed up in one nice handy-dandy little table there. And then I defined some things for you, because through the years, students have asked me, what's LC stand for? Leading coefficient. What's that arrow mean? Approaches. What's an f of x? It's y, or the value of the function. Right? So f of x just means the value of the function when x is whatever you plug in for x. Right? It's the value of the function. Right? If you have any questions on this, happy to go through this again with you in class. We're going to do some problems together before this podcast ends. And that will help you even more. Right? So let's look at this one. Right? We're going to identify the end behavior. So we're going to use the leading coefficient test to determine the end behavior of the graph of the polynomial function f of x equals x cubed plus 3x squared minus x minus 3. So notice it's SE shaped, and it's x cubed, and it's got stuff with it. It's got an x squared term and an x term and a constant. Because the degree is odd, n equals 3, and the leading coefficient 1 is positive, the graph falls to the left and rises to the right, as shown in our figure. But that is not how we're going to write end behavior. Falls to the left, rises to the right. That's not describing, that's not mathy. We're going to put it in correct mathematical notation. Right? So we're going to identify what's the function doing as x approaches negative infinity and positive infinity. So f of x approaches what as x approaches negative infinity? Right? Well, if it's falling to the left, right? It starts low. What's low? What's falling? Low is negative infinity. And f of x approaches what as x approaches positive infinity? Rising, ending high. What's high? Positive infinity. Okay, so it's going to approach positive infinity. You just do that little mantra, that little cheer all the time. you'll remember it. All right, so we've identified our end behavior for this particular graph. And the graph is really pointing the direction to you. You'll notice the end is pointing to the left, pointing to the right. But we don't even need a graph to be able to identify end behavior, and this is in your notes. We're going to determine the left and right behavior of the graph for each of our polynomial functions. And we have everything in there because when we're identifying we're identifying end behavior, we need to look at the degree, we need to look at the leading coefficient, and then you think of the basic shape. Right? It's not a graph, it's just the basic shape. And that will help you with end behavior. Here, by the way, I have a y as opposed to f of x. Right? I borrowed the questions. The y was in there instead of f of x. Really should be an f of x, but f of x doesn't really mean y. It's just not. It's like a nickname for f of x. You know? So if your name was Joseph and you're called Joe, that would be your nickname. Well, y is f of x's nickname. All right, so let's take a look at our first one. F of x equals x to the fourth plus 2x squared minus 3x. We're going to look to the largest exponent. There he is. He's 4. 4 is the largest exponent. That's our degree. And then on the blank there, put 4. The degree is 4. Leading coefficient? Just look at the coefficient in front of that term with the exponent. That is 4. All right, so x to the fourth has a coefficient of 1. That's positive, right? So we have even degree and leading coefficient's positive. It's like a cheerleader, both arms in the air, right? So it's going to have this shape. It's probably going to have kind of like a W shape, quite honestly, because it's got an x squared term and an x in there. So I'll put kind of a little W shape there. But it's really not important if you draw this as a U or a W, right? Either one is fine. It'll still tell you your end behavior. So notice both sides are in the air, right? Both sides going high. What's high? Infinity. All right, so as x approaches, oh, and by the way, not only do they have y in here, y should be first because y is what we're concerned with. But no, they have x. Right? We know x goes everywhere. What does y do? All right, so as x approaches negative infinity, y, and both sides are high, it's approaching positive infinity. And as x approaches positive infinity, y approaches positive infinity. Right? So no matter what x is doing, both ends go up. Right? And so that means that's going to be positive infinity. Let's look to the next one. F of x equals negative x to the fifth plus 3x to the fourth minus x. Degree, look to the largest exponent. Degree is 5. Look to the coefficient in front of that term with the largest exponent. Leading coefficient is negative 1. Basic shape. All right, it's going to be SE because the degree is odd. It's going to go down left to right like a line with a negative slope. All right, so it's going to be a SE that starts high and ends low. If it's starting high, that means as x goes to negative infinity, y has to go to infinity because high is infinity. As x goes to positive infinity, y goes to, right? So it starts high, ends low, right? So if it's low, what's low? Negative infinity. And then finally, we have f of x equals 2x cubed minus 3x squared plus 5. Degree, look to the largest exponent, is 3. Leading coefficient, look to the coefficient right in front of it, it's 2. Basic shape, right? Odd, it's going to be SE. Now it's positive, right? So it's not going to go down left to right. It's like a positive slope. It's going to go up left to right, right? So it starts low, ends high. As x approaches negative infinity, y starts low. What's low? Negative infinity. And as x approaches infinity, it ends high. What's high? Positive infinity. And there we go. We've done it. Easy cheesy, lemon squeezy. And then you have this in your notes so that you can refer to it. And when you get stuck on end behavior, just look at this, look at that other page. We're going to do one last thing together, and that is we're going to do a matching. Now I want you to be thinking in your head, which one is it? All right? So you be thinking, where should I put 1? All right, and then you can tell me, did you get 100%? Did you get them all right? Or did you get confused, but now you know? All right, so number 1, f of x equals 3x to the 4th plus 4x plus 3. Largest exponent is 4. That's even. Means both ends go together, right? Either both ends go up, both ends go down. Is it up? Is it down? Look to your leading coefficient. It's positive. Do you know where I should move number 1? Do you got your answer in your head? You can shout it out at the screen. It's fine. Go ahead, shout it out at the screen. If you said 1 belongs at D, ding, 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 you are correct. Number 2, f of x equals x to the 5th plus 1/4 x plus 1. Exponent's 5. That's odd. Leading coefficient, we look, the coefficient's 1. That's positive. I'm not giving you much help on this one. Now, which graph here is odd degree but has a positive leading coefficient? Where should I move number 2? If you said I should move number 2 to A, barely move it at all, ding, 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 you are correct. All right, number 3, negative 5x cubed minus x squared plus 4x plus 2. Degree, odd. Largest exponent is 3. Leading coefficient, coefficient on x cubed, negative, negative 5. Which one do you think it is, B or C? Go ahead, shout it at the screen. Where should I move it? Should I move it to B? Should I move it to C? If you said I should move it to B, you are correct. That is the negative 5x cubed minus x squared plus 4x plus 2. And of course, the last one, it has a degree 6. That's even. Both ends have to go together. Leading coefficient is negative. It's gotta be C. And that's all there is to it. All right? So sometimes you don't need to solve anything out to match an equation to a graph. If all of them have a different shape, just look to the end behavior. Look to the degree. Is it odd or even? Look to the leading coefficient, positive or negative. That'll tell you all you need. And I think that is the last thing I'm covering on end behavior in this lesson. If I see a screen, a blank screen, a covered screen, then that's it. All right, so in the next lesson, we'll look at something else related to graphs of polynomials. What will it be? You'll have to come back and find out. Bye for now.